Well, good morning. I may not be as sparkling as usually. My body is here. My brain is still somewhere, traveling from New Zealand. So if I stumble over a few words, please, my apologies. I'm not sure what happened to make me the old man of the field, and I suspect by default everybody else stepped aside or worse, and I'm going to remonstrate somewhat with the community. Before that, though, I was pleasantly surprised. On Thursday, I was attempting to sit one of my favorite places on the planet, on the Spanish Steps. You can't sit in the Spanish Steps anymore, but having been whistled at by the police lady and told to move on, I saw the lady next to me had a newspaper which had the headline, Fusione Fredda, and I thought, fantastic, amazing. We finally had the recognition that we deserve. So I invested a very large sum of 1.5 euros and bought the one and only copy of La Repubblica that I will ever buy. And sitting peacefully over a bottle of red wine, I transliterated this painfully, word by word, to find out.
It was another kind of fusion. Eh?
To find out what it was about. Because clearly it's not about us, but the sub-editor that chose that headline had a high degree of freedom as to what headline they put up. So I can't help but believe that this was intended as a positive jolt to the cold fusion community. That is what I choose to believe. Our field faces two major problems that are significantly impeding our progress. The first problem is old age, and I don't need to explain to this group, that really is a problem. I've put this wall of, retired heroes up to remind me of two things, however. There are worse things than old age. And every one of these gentlemen on this wall here, Bockris, Case, Fleischmann, Ariani, Torbert, Chubb, and Arata, produced their genius-level ideas at an age greater than the age that I'm presently at. So there is hope for me. But old age brings with it some concomitant consequences, which I'm becoming increasingly familiar with. There's a shortage of fresh ideas, a tendency to repetitive actions. And I watched some research groups that I was very close to simply fall into the trap of doing the same thing over and over and over again. It's also a failure to act. I see Microsoft has done its little thing and put a face where he shouldn't be. But there are a number of things, and I'm talking about me now. There are a number of things that I thought to do, experiments that I wanted to perform, that I never got around to performing. Other metals, alloys, higher temperatures. I mean, it is essentially pointless to produce heat at 30 degrees centigrade. We did almost all of our experiments at 30 degrees centigrade. There's no market for heat at 30 degrees centigrade. 300 degrees would be a very, very reasonable number. In fact, probably the optimal. But very, very few experiments have been performed in that temperature regime. Other electrochemical modes. I'm an electrochemist. Fleischmann was an electrochemist. Martin Fleischmann, in fact, invented the electrochemical fluidized bed. Fluidized bed of palladium particles or alloy particles would be a highly plausible system in which to generate excess heat. Martin actually had an experiment which he set up. Mel Miles ran it once in Japan. And nobody else has touched it since. I worked on this. The topic of my postdoctoral work in Southampton was electrochemical fluidized beds and packed beds. I understand the systems very well. I understand their power and relevance to this field, and I've yet never done such an experiment. In old age, we also tend to fail in adoption of modern methods, and we clearly need to enlist young people to, help us as we dodder along. The second problem we have, and this is a strong and serious comment, we communicate poorly. We communicate poorly inside the in the community, and much, much worse, we communicate poorly outside the community, as the recent Google exercise evidences. Oops, wrong way. So I would some power the gifty geas to see ourselves as others see us. It would from money a blonder free us, and foolish notion. Robert Burns on seeing a louse in a lady's bonnet. We need to see ourselves as others see us. This community is quite closed. We all know each other. We communicate with sort of an inside jargon, but this room is filled with wonderful people who have done wonderful things, but the people that matter, the people that we need to communicate to, are outside of this room. So we should really think about how we communicate our successes outside this community. Thinking of the recent Google exercise, and I'm going to point to a representative of that exercise in the front here. Our field was recently joined by a new group of people, able and intelligent people. I knew essentially all of them, very well motivated, hand-picked from relevant disciplines, selected from good institutions at almost the highest level. If you choose from the very highest level, then academic ego becomes a problem. So you really want the next tier and to do actual work. These people are young, have fresh ideas, young enough to be uncontaminated by the stigma that was very effectively imposed in 1989 and 1990. My view is that any scientist under 45 you can communicate to. Scientists that were active and lived through the drama of the Fleischmann Ponds announcement, March 23rd, 1989, their opinions are rigid. Very, very few of them can be persuaded, and I don't even try. The effort was well-planned, well-guided, well-backed, and funded with essentially unlimited money. I mean, the biggest problem that Google faces, they make $2.2 billion of profit every month. Disposing of that money wisely is obviously a headache, not one I've ever had to deal with, but clearly a headache. And it's a strategic effort, strategically planned and ongoing. So the Google mirror, what happened? What should we see reflected in the Google mirror? Revisiting the case of cold fusion, and one of the authors of this paper is sitting in the front row or second row here. What the Google team wrote, something like 12 publications, and what was written about them, another dozen or so publications, is highly reflective of how the well-disposed fraction of the outside community sees us. people that are not well disposed, people that are still contaminated by the drama of 1989, there's no interest in communicating with those people. Well-disposed people are telling us how they see us, what they have learned from us, and it would be very foolish to avoid learning the lesson, to see ourselves as others see us. I was part of the activity in 2015. I can assure you that the Google team did not listen. They listened keenly. What happened is we did not effectively communicate. I'm not going to name names or point fingers, but the effort was a genuine attempt to learn, and we didn't effectively communicate. That's not their fault. It's our fault. In 1920, at ICCF21 in Fort Collins, I said the words in blue and annoyed some people and some people that are in this room today. But I very much believe it, and I'll restate it today perhaps more precisely. This field lacks a clearly and fully specified written protocol to reproduce even semi-reliably, and I would accept half the time, any aspect of our claims for cold fusion or condensed matter nuclear effects of any sort. We do not have a piece of paper which can be taken away and followed, and if followed by one of normal skill in the art, would produce the result, a nuclear effect, tritium, helium-3, helium-4 in non-natural ratios, excess heat at the watt level for hours, something that is clear and unmistakable. We don't have such a procedure. If we did have such a procedure, we would be vastly ahead of where we presently are. We would not have, the problem we would have would be quite different. It's just the fact that we do not have such a procedure, cannot make a procedure available to others, such as the team that Matt Trevithick put together at Google. If we give them a procedure that they would follow, they would run with it. They would very quickly lead us. We would be following, trailing behind, and despairing that we can't keep up. But we don't have such a procedure. I was asked by staff at Infinite Energy to write a critique of the Google work. And I led with the phrase, "God bless Google." Now, I've never said that before. Never even thought that before. May never say it again unless it happens that we can give Google this procedure and that they take the lead in this activity. The four things that I called out as being conspicuously noteworthy were the vision and action. And Google had decided, in its semi-infinite wisdom, that the solution to mankind's future energy problems cannot be found in the renewable energy sources that we are presently building up, windmills, photovoltaics, whatever. Renewables will not solve man's energy problem. What is needed is for a primary energy source that is reliable, safe, cheap. And only two things, in my view, are capable of meeting that criteria. Google's vision is a little broader, and in Google's mind, hot fusion, conventional fission, and cold fusion might solve that problem. I don't think hot fusion will ever be economic in that scheme. So I see only two ways forward. Either advanced fission systems, fourth generation, possibly thorium systems, that can solve the problem. It has some attendant risk. The other thing that can solve the problem is cold fusion. And what Google did is acted on this vision. They set up a program, put $10 million into it, put a team together, and set out to see if if cold fusion could actually do the job. And the question is still open. It's still under investigation. Second thing that Google did was publish in Nature. Now, those of you who remember 1989 will, and the furor that associated with the initial announcement will remember and understand how significant it is to get a publication in Nature of any sort, other than condemnatory. And on the 30th anniversary, more or less, it was really a wonderful achievement. Confirmation of the loading ratio that was first noted, and you need a loading ratio, or to achieve at some point a loading ratio of 0.85 in the DPD system. But the thing that I really pointed out was the fact that Google had pulled together a team of young people who had become interested and remain interested in pursuing this field. And they, in fact, have possibly saved us from inevitable demise. I have two quotes here, both quoting me, of course. One by Trevor Dardick, who is one of the young people that I have brought into the field. The younger participants can help make scientific advances by actually doing science that will bring the research into a new light. And today I will say, without active youth participation, we will fail to complete Martin Fleischmann's dream and vision. Nothing I've said today, or ever really, should be taken as indicating that I don't remain strongly persuaded that, to shorten this, cold fusion, condensed matter nuclear effects do occur more or less for the reasons that Julian Schrenger pointed out in 1991. Unlike the near vacuum of hot fusion, the ambient environment of cold fusion is the lattice, which is a dynamical system capable of storing and exchanging energy. What Stan and Martin discovered was not cold fusion or deuterium to helium-4 electrochemical system. What Martin and Stan discovered was vastly bigger than even they imagined. They discovered condensed matter nuclear effects. I'm going to skip this in the interests of time, and I've basically said what is on this slide. What does my mirror look like? I'm going to cut through this too because my chairman is chastising me, but we had 3 episodes of highly repeatable excess heat production. A Fleischmann-Pons experiment, a series of experiments that were run, statistically significant excess heat in every one of these experiments. We thought we had the problem solved. This was back in 1990. Cool, we got it, we understand it, we know it. The material that we were using ran out, the effect went away and went away for a long time. Could I do this again? No. I couldn't do it again. I'm too old. I'm not willing to put the time in. I don't have the focus. But more importantly, I don't have the team of really quite brilliant people around me that is needed to run an experiment as difficult as this. I have a list of people listed here. Every one of these people has contributed hugely to the success of our undertaking. And not only was I lucky to be in the right place at the right time with the right training and the right resources available, and all of these great people around me, we were lucky. Bottom line, we don't quite know how it works. And Bill was asking, what it is, if we don't even know what the fuel is or haven't observed the fuel and the consumption of fuel. We don't quite know what it is or how it works, but we know it can be done. And it's already given indications that it might be useful. And people have energy gains of, 25. Heat produced at 100-degree temperatures or more, where it really is useful. So we suspect, we know the effect is real, we know the effect is nuclear, we know or suspect that it might have some practical value. And as I've said many times before, if we can tap the power of the nucleus safely, cheaply, reliable in a tabletop device, if we can wield the power of nuclear physics on a tabletop, it must be good for something. Conclusion, we got to look in the mirror and learn from the way that others view us. But the words in bold are really the cornerstone of this presentation. Given what we know now, what do we do next? What strategies move us forwards? This slide, partly in commemoration of my very good friend Mike Mielich, who passed recently, but Mike's loss is huge because Mike was one of the very few people in the community who thought in a strategic way. The other person whose cheerful face you see up there is Matt Trevithick, who also thinks in a cheerful way and in a strategic way too. He's down the front, come and beat him up afterwards, and better still, offer him tangible strategies to move this field forwards. With that, I thank you.
Question?
Okay. Thank you very much for your talk. On strategy, my personal strategy over the last 8 months is to use what condensed matter nuclear effects appear to do, that's not produce radiation, to recognize that fission is something that's going to be doubled in capacity between now and 2040. This is a reality. And can we use the work of, for instance, Alla Kolanova and Vladimir Vysotsky in mitigating the use of fusion, and also Dr. Ruichi Namaza, who have just come back from Japan, who it appears to remediate nuclear waste both in liquid form and solid form from fission reactors. These technologies are where we can have a strategy to use what LENR can do, which may or may not produce excess heat, to enable what we do know produces excess heat. That's my point.
Thanks.
Excellent.
Yeah. You wanted a strategy? There's one.
I have maybe two comments, more comments than questions. First one about experimental replication or replicable experiments. In the last 8 years, I have been deeply involved in battery research, and I can guarantee you that if you look at scientific literature and take interesting battery inventions and try to replicate them, you will come to a conclusion that batteries don't work. But this is contrary to everyday experience. So it means that somebody has to take the effort from all the reports to select those which are replicable and work. And we have a lot of publications in the last 30 years, so just somebody has to go through them and do the selection. But that's the question, who and why would fund that activity. So I would pose that question to Google, why they don't try to do that. Then
Why did they try to do what?
to just go through all the reports and try to select what's replicable, what works.
Well, I've just said that nothing is replicable.
Well, that would be too sad. I hope there are some exceptions.
But in any case, whether replicable or not, what I'm asking for is a written procedure. I want a piece of paper. You can have 2 pages if you like. Put down a procedure. You do this, you do this, you do this, you do this in this environment, and this is what you will see. And I'm going to let you only succeed 1 out of 2 times. I'll give you a 50% failure rate.
Last question, Celani, and
just a comment about your opinion, the way that about your claim that there are not experiments at high temperature. Maybe you just forgot our efforts, and now we are working routinely at a temperature over 500 degrees. Now we reach about 800. In the core of the reactor, outside about 300. So I think this point has to be quoted. Thank you.
What I said was that the chastisement was to me. I didn't run experiments at 300 degrees. I ran my experiments at low temperatures. I am well aware of other people working at higher temperatures, yes, and including your work.
When we talk to people and tell them about cold fusion and try to communicate, and for instance, university professors, and they say, I got my nature, and nature was pretty clear on this doesn't work. What do I say? How can I respond to that? What is the explanation for this?
Well, a person that makes that statement is not worthy of communication. And that is not at all what the Nature conclusion was. The Nature conclusion was quite neutral, and it was very clear from what was said by and about the team that they intend to proceed. If they believed that they had demonstrated that the effect was not real, they'd have simply, washed their hands and gone on to other things. And I think to a man, you can ask Matt about this, to a man and woman, they all intend to proceed because they are excited with what they have seen. Have they solved the problem with $10 million and 4 years of effort? Hell no. We didn't solve the problem with 10 times that amount of money and 30 years worth of work. But that doesn't mean there isn't an effect. So I think what you're listening to is knee-jerk 1989 Luddite thinking, right? And it's people like that, like people wearing their baseball caps backwards. I love that.
Okay. Thank you. Un applauso to McKubre.